Hello everyone, and welcome to 3D Vision's How to Solve It webinar series. Today we're going to be talking about successfully importing your CAD model into SOLIDWORKS. My name is Chris Snyder. I'll be your host. And just a quick housekeeping note, if you have a question, you can type it into the GoToWebinar chat window. I'll do my best to answer those questions as we go. Got a lot to cover, so let's jump in. CAD has many formats. It's kind of like different languages. So if I want to speak, go to a foreign country, I need a translation in order for that communication to be meaningful to me. So for instance, if I'm going to a Spanish-speaking country, I might want to take Google Translate along with me. It's a tool I've had success with in order to translate things back into English. In the CAD world, however, we're talking about different types of third-party CAD systems, and we're talking about speaking SOLIDWORKS today. So how do we get those languages in the CAD world to speak SOLIDWORKS? Well, we have translators for that, but they're subject to translation. Sometimes it depends on what language you're using or how well the interpreter is doing. So for instance, in going from Spanish to English, we might use Google Translate and find out that that does really well and translates Spanish into English, and it's very meaningful information to us. If we're talking about CAD, however, we have a third-party CAD system, and we happen to use an IGES file translation to get that into SOLIDWORKS. In our experience, a lot of times we find problems with that translator, and so there's additional things that we need to do on the SOLIDWORKS side in order for that translation to be meaningful to us. So let's look at our agenda for what we're going to talk about during the webinar. We're going to talk about import formats, what we should use. We're going to talk about diagnostics, how we can deal with issues that come up, and then we're going to talk about repair options. So once we find something that needs some work, what options do we have there? And then finally, there's a brand new tool in SOLIDWORKS 2017 that I want to introduce you to called 3D Interconnect. So with regards to what 3D CAD can SOLIDWORKS import, and again, we're just talking about three-dimensional CAD today. We can import 2D CAD, but we're going to focus on 3D CAD. We're going to focus on the more common or most popular formats. So there is a neutral format preference, and this is sort of like a third party or a third language, if you will, that we want to go from a third-party CAD system into SOLIDWORKS. We're going to translate it into this neutral format first. The first one we want to talk about is Parasolid. It is the modeling kernel used by SOLIDWORKS, so that's why it's the preferred neutral format. It's actively maintained by Siemens Corporation, so we put that at the top of our list. Secondly is the STEP format. It's the standard for the exchange of product data. It's actively maintained by the ISO organization. One note here is that the 242 format is also going to include the PMI data if you're looking to do some of that translation as well. STEP will carry that information. Third on the list, we're going to list the ASUS kernel. That's actively maintained by Dassault Systems Corporation. And then we can't go without mentioning IGES. That's been around for a long time. It was originally developed by the Air Force, but the last update was in 1996, which was quite some time ago. So if at all possible, we tell people to try and avoid that, that neutral file format. Next is native CAD file formats, and actually this is, we're going to put this in front of the neutral formats, just eliminate that neutral translation altogether. Top on our list is CATIA V5, parts and assemblies. This requires a separate license for you to be able to read this into SOLIDWORKS. Everything else will read in with just a standard or and above license. Inventor parts and assemblies, version 11 and above, and you have an option to recreate or import the feature history here. Pro-E and Creo parts and assembly, same thing here. We have an option to import feature history in addition to just importing the geometry, and we can handle up to version 3.0. Solid Edge parts and assemblies up to Solid Edge with Synchronous Technology 6, and Unigraphics parts version 10 and higher, including NX9. Okay, what are the benefits from importing files? We have the ability to view and make changes to geometry without the native CAD system. So if someone sends you a file and you're going to make it and you need to add drafts, well, you're going to be able to do that after importing that file into SOLIDWORKS. With the native CAD file import, as I mentioned, there are fewer translation steps. So we can go directly from the native file directly into SOLIDWORKS, and we get the option of trying to create a feature tree with Inventor and Pro-E. Now I say trying because it's not always successful. When it works, it's great, but we'll talk about that, why that might not be possible in a minute. And then finally, we want to remind you to use the preferred formats first. Get the native geometry if you can. If you can't, use Parasolid, and then third on the list is the step format. Let's switch gears and talk about diagnostics. So why do I need to do import diagnostics? Well, if you look at your native CAD file, native CAD geometry, and then you look at it after importing into SOLIDWORKS, if you see that you're missing some geometry, that would be a pretty important thing to be aware of and also to fix that. So we have some tools built into SOLIDWORKS to deal with this. So our goal is to get three-dimensional solid geometry, and as I mentioned, there are times when that might not be possible, and here are some reasons why. Different tolerances, different CAD system may use rounding, different precision, which causes rounding errors. So when you translate that, the SOLIDWORKS may not read the math the same way as the third-party CAD system, so you might see some errors caused by that. Translation mapping, not all CAD systems support the same features, so there may be some struggle on SOLIDWORKS end to translate what was originally created in the third-party CAD system. And then finally, some surfaces just don't translate, and you'll see holes in the model, and you'll have to fix those in order to have solid geometry, which is our goal. So what does import diagnostics do? Well, it helps locate and fix problems with imported geometry. So let's just jump into SOLIDWORKS here and take a look at what happens. So we're going to import an IGES file in this case, and if you change the filter to the preferred format that you're looking for, you can click on the options button and do things like automatically turn on the import diagnostics. In this case, we're going to leave it off and go ahead and open the file and see what happens. It looks like it's read in pretty clean. We're going to right-click on the imported feature that we've got and choose Import Diagnostics. This is a very important step that you want to do when importing with the current tool. We find that we've got a problem with this face. We can right-click on it, zoom to selection, figure out what's going on, maybe right-click and do a what's wrong. Sometimes that's helpful. We've got some individual tools here to try and repair or even delete that face and just recreate it. But Attempt to Heal All is the closest thing we have to an easy button, so we'll choose that. SOLIDWORKS fixes that for us, and we're done and ready to go. So this is a valid solid at this point, and we can be very confident of what we have in SOLIDWORKS at this point. So as I mentioned, Import Diagnostics helps locate and fix problems with imported geometry. It identifies problem areas, faulty faces or gaps between faces, provides automated tools to repair problems. So if you right-click on a face, you can find Repair Face or delete it or recheck it if you've worked with this a couple of times. Under the gaps, there's 3 different tools: Heal Gap, Remove Gap, and Gap Closer, and those are just, why are there multiple things? Well, if one doesn't work or doesn't give you the exact results that you want, you have other tools there to use. Attempt to Heal All, you see that kind of in the background there, but then there are a couple of grouped sections down at the bottom. Attempt to Heal All Faces and All Gaps. Maybe it makes sense to try and do the gaps first and then the faces next, instead of trying to do everything at one time. Our goal is to ensure that we have a valid solid, and this is what we want to see eventually, that we have no faulty faces or gaps remaining in the geometry. Import Diagnostics doesn't always work. It's not I mentioned there's a magic button, but when it doesn't work, there are several options. One is just to simply run Import Diagnostics again. So we run it, we find a gap, the results say, hey, there's still a face, there's a problem. We're just going to click Attempt to Heal All one more time, find out that on the second pass, it was able to fix that face, and away we go. That was easy. Second option we're going to bring up is called round tripping the model, as I refer to it. And then what we're doing here is we're just going to simply export the file out as a Parasolid file from SOLIDWORKS and then read it right back in as a Parasolid file. Sometimes allowing the import process to reassess the geometry really helps to clean things up. Change the import style. If you've got an IGES file and you're having real problems with it, try and go back and get the native format or one of the preferred top 2 formats, either parasolid or step, and see if you get better results with that. And then lastly is just plain old, good old hard work, where we recreate the problem surfaces in this case. So let's take a look at that in SOLIDWORKS and show you what that looks like. So in this case, we'll open up a step file. And after opening it up, of course, we're going to do our import diagnostics. We do that every time. Find out we've got some faces and gaps that we're going to have issues with. In this case, we're going to heal all the gaps first, and then we're going to attempt to heal all the faces. And we run attempt to heal all faces a couple of times, and eventually we're going to find out that we've got one face that's just a problem, and we can select it to highlight it, or we can right click and zoom to selection like we did before. But in this case, we've kind of come to the point where our automated tools are not going to do the trick for us. So we're going to switch over and use some of our surfacing tools. So surfacing tools are going to come into play here as we're copying or offsetting this surface 0 millimeters. We're going to delete some of the geometry in the solid and use these surfaces that we've copied over as a basis for creating new surfaces. So if you've not been to surfacing class and you're doing lots of importing, see here we're doing a delete, getting rid of those, you might want to consider coming to training for that, or learning more about how to manipulate surfaces in SOLIDWORKS, because you'll be spending some time here if you run into issues. So in our case, we're just simply going to take the copied surfaces, which are just nice planar surfaces, extend those edges appropriately, and that'll give us some trim tools to work with. So that's another surfacing tool that you're going to be using a lot, trim surface. And that'll give some nice edges that we can put a fillet on. So first of all, let's take care of the trim. We identify the surfaces that we want to trim, and then tell it what we want to keep. And what we end up with is some nice edges to work with for our fillet tool. Of multiple radiuses, option turned on. So you will have decided ahead of time, of course, what size these fillets need to be, but we'll go ahead and change one of these just to make it interesting. Okay, so now we have some nice surface geometry, and we can turn on the other surface that we've got and knit those together to create a solid. So remember, that's our goal, is to come up with valid solid geometry. In this case, the automated tools didn't work, so we went out and created some surface geometry of our own and cleaned that model up. We have now a valid solid to work with. So let's review those. We've used just a few of these tools to recreate problem surfaces. We used surface offset. We used delete face. There's also a couple of sub options there to patch and fill, so it's actually going to create and fill the gap that's going to be left when you delete those faces. So that's something you want to investigate. Surface trim we used, and also knit surface to sew it all up and make it into a solid again. Another tool that you might want to look into is called spline on surface. Could be really handy to copy a surface out, trim it up, and trim it based on a spline that you draw directly on the surface. Using 3D geometry, that could be very useful. Also, you want to learn more about filled, loft, and boundary surfaces if you're creating surfaces yourself to fix the ones that didn't come in. Replace face is another quite useful tool that you want to look into. And check entity is another tool for diagnostic use in addition to the import diagnostics that you want to look into. So what are the benefits of the repaired model? The model is going to be ready for downstream edits, including FeatureWorks, where if I want to create features out of or directly on the dumb geometry, as we refer to it oftentimes, we're ready for that. There's a smaller file size. If you've got one solid versus multiple surfaces, you'll see that the file size oftentimes is a lot smaller, opens up quicker, and there's lots of benefits there. So definitely make sure that you've got valid solid geometry coming in. And then finally, there aren't any issues using this in an assembly or a drawing. So if you leave it as surfaces, or if you have some gaps or things in the model, you may end up finding issues when you try to use mates or places in a drawing view. So we've seen some of those in the past. I wanted to save some time to talk about a new tool in 2017 that's just come out this week called 3D Interconnect. This is cutting-edge 3D multi-CAD data referencing technology. So I want to introduce you to that, but we're talking about moving from third-party CAD systems into SOLIDWORKS. So the neutral file formats don't qualify for that. They're going to be left just exactly the same as they have been. But let's jump in and take a look at this. What I did was I went out to GrabCAD just to have a baseline of how translating files is greatly improved with 3D Interconnect. So you can see the GrabCAD file on the screen here, and you can go look that up yourself if you want and take a look at it. It's Inventor 2016, has 759 components. So what I did first was import that using our currently available import tools in 2017, and you can see the image on the screen there. Took almost 13 minutes to go through that process. It required me to install Inventor View, so some more software that I needed there. And if you take a look close at the bucket and the tire, I'm pointing those two things out. There's lots of import diagnostics required, going to be required to repair this geometry. It doesn't come in very clean, so we need to make sure that the important parts at least we've done the import diagnostics on that. So that's going to take quite a bit of time. I didn't do that, but I can just imagine that's going to be hours of work there. And there's no link back to the native file. So we're going to talk more about that in a second, but just make note of that. Well, here is the results from 3D Interconnect. So the exact same model. It came in just under 4 minutes, so over 3.5 times faster, which is fantastic. I'm really pleased with that result. No additional software is required, so I didn't have to put Inventor View on my system, and no import diagnostics required either. If you take a look at the model on the screen, the bucket and the tire that we pointed out earlier are looking a lot better than what we experienced with using the import tools. In addition, there's a link back to the native file. We're going to show you what that means in a second. So let's compare the import process versus this new tool called 3D Interconnect. I think it's a no-brainer. 3D Interconnect is much faster. Imported actually does the translation in the background. I'll show you that in a second. The geometry results are much better. There's a link back to the native file that you can use for updates, and it's simply as easy as a file open. So let's take a look at that in action. So here's a little flashlight, and we want to insert some batteries to show those. So we're going to do insert components, and we're going to go out and find our battery files, which happen to be Inventor files. So it's not a translation, it's just as easy as a file open, and we happen to be opening an Inventor part. So just that quickly, we didn't speed the tape up or anything like that, but that comes in to our SOLIDWORKS assembly, and we're going to speed this part up where we're adding some assembly mates just for the purpose of this webinar, obviously, but we just want to get those kind of in a place that makes sense, and we'll slow it back down to normal speed here. And what we want to do is attach this extrusion to one of the faces on the battery. So these are not just geographical representations of the batteries. There are surfaces and faces here that we can choose from, so that the body of the flashlight now can be related back to the geometry of those batteries. And why is that important? Well, here's where the link back to the original file comes into play. So what we're going to do is simulate that file's been overwritten. We're going to copy from another location, paste it right over top of the original file. So this is going to say, hey, somebody changed the battery in Inventor, and we're going to come back to SOLIDWORKS and see what effect that has on our assembly where we've inserted these battery cells. So we're going to right-click on that component. You'll see an update model. So it's a semi-automatic update here, is what I call it. And just like that, we'll see that our SOLIDWORKS parts that were related back to those batteries have updated. You can also see that we've got some issues now with some interference. So there might be some other changes that we might need to make to the model with regards to dimensions and so forth to get rid of that interference. So that's great. We didn't have to worry about import diagnostics or anything. It's just like it was a SOLIDWORKS model to begin with, and that's the point. Let's take a look at another example here. In this case, we're going to use a Creo part. So Notice that it's a .1 extension. That's how Creo keeps track of revisions. So we're going to open this up in its own window as a part, and it does create a SOLIDWORKS part, but it has an external reference back to that original Creo file. So we're just going to make a super simple addition to this, put a little extrusion in here to demonstrate that we're adding something to this model that we've imported and have this link back to the original CAD file. Right, so nothing terribly complex, just to demonstrate, hey, there's the Creo part link, and then here's the boss extrude that I just added. So with that, we're going to insert this back into our SOLIDWORKS assembly and have it be part of that. So we haven't done any file import, haven't done any import diagnostics yet. We have very good geometry to work with. It's been almost exactly like working with a native SOLIDWORKS file, which is great. Sped up the video here a little bit to show how we're going to assemble that, and then we're going to walk through an update. So somebody has updated the Creo part. So you see the .2 extension. We're going to paste that into our window here and show that on the screen. Come back to SOLIDWORKS in the assembly and switch over to the part window, and it's hard to see, but there's a little update icon there indicating, hey, a change has been made, and we're going to right click and choose update model, and you can see that there's been a shelf added to that. But the important thing to note is that the features that we added downstream have not been moved or deleted, and they're not lost, right? So all that work that we did to put that button on there maybe is still there through the update process, which is great. And then lastly, if we wanted to get back to the place where we just had the imported geometry there, or the imported feature rather, we can get that by breaking that link. So the link is there by default, and what it's meant to do is make the process of translating data more seamless, so that all that translation happens in the background, and it's more like just opening a native file almost. So here's the slide again with regards to what we can open from our friends at PTC, Solid Edge, NX, Inventor, and CATIA. So CATIA requires the SOLIDWORKS Premium license. Everything else you can, it comes with SOLIDWORKS Standard and Professional. So give us a call if you have more questions about 3D Interconnect. Let's wrap up here. What we talked about was import formats. We want to make sure we use the preferred formats, start out with native files, and then move into some of the neutral file formats. So remember, we talked about importing with the currently available tools first. That we can use diagnostics to automatically find and repair problems, and if that doesn't work, we've got some repair options that we can try and get high quality 3D geometry with. And finally, we showed you 3D Interconnect. It's a brand new tool in SOLIDWORKS 2017. It's a next generation translation tool. It takes much less time to bring parts from third-party CAD files into SOLIDWORKS, and it's greatly improved results as we showed, and now with option of having file links. So thanks for your time today, and be sure to fill out the post-webinar survey to request a quote, a demo, or more information. And be sure to check out our next webinar next week entitled Make Your SOLIDWORKS Files Smarter by Moving Them Out of the Network Drive and into PDM Standards. So that's Wednesday, October 12th, and it's at the same time, 10 o'clock. So it doesn't look like there's any questions, so I'm going to close the webinar down, and thank you again for your time. Have a good day.